Standard scores is another concept that you need to be able to understand. Standard scores result from when the raw scores of a test are changed so that they represent a more standardized format. This way you can take two completely different set of test scores and you can compare them. Let's look into this a little bit. While there are many standard scores, we're going to look at the z-score. The z-score is a standardized score on a metric, like standard deviation. And the z-scores compare scores across a distribution. To calculate a z-score, I look at the individual score on a test, the mean of all the test scores on the same test, and the standard deviation of the test. Using these factors in the equation listed on this slide, you calculate the z-score. At this point, you're probably wondering, why are we doing this? Why do we need standard scores? One of the good things about standard scores is that in this case, z-scores, if they're negative, it means they're below the mean. If they're positive, they're above the mean. And a z-score of 0 is the mean. The score doesn't deviate from the average or the norm. Therefore, the z-score equals 0. This is just a pictorial representation of z-scores. Again, the mean, that z-score is 0. Positive z-scores are to the right of the mean and negative to the left. Adding to this discussion, z-scores are equivalent to standard deviation. Most of us have heard of those, even though we may not fully understand them. A z-score equals one standard deviation. So you may be thinking, why do we even bother doing this? Why use a z-score instead of a standard deviation? If we have two different tests, the standard deviation for a set of scores on one test is unique to that particular assessment. The standard deviation for the second set of scores on a test, on a different test, is unique to that assessment. The z-score will always represent the same relative position. That's the advantage of a z-score. So let's look at an example. Test A. Say the mean of scores on Test A is 75, and the standard deviation is 15. One standard deviation equals 15 points. It equals one z-score. But take a different test, and the mean on that test is 20. The standard deviation is 3 points, but the z-score is still 1. It's the same relative position. This will help you have a better sense of where a score is or the distribution of scores is on a particular assessment, but you can also compare them. If this seems confusing, reread the section in your text. And ultimately, for this class, you just need a general understanding of both the standard deviation and a z-score, in that they both describe a set of scores, and they both talk about the relative position in a set of scores. You may need to reread this in your book or look at this again, but you just need to know this in general.